Most of the teams know testing pyramid, yet still struggle with slow and unreliable tests. In this video, I will explain you how testing pyramid actually works on real-world system. My name is Matúš. I am senior test automation engineer with over 8 years of experience, and on this channel, I explain how test automation and software quality work on real-world systems. So let's start with the question, why testing pyramid actually exists. Testing pyramid is a model that helps you to reason about speed of feedback, confidence, and cost. And it's important to understand it is not a strict rule about how many tests you should have at each level. From the nature of software development, earlier you find a bug, the cheaper it is to fix. If you discover a problem while implementing simple method, you can fix it immediately. But if you find the same issue during end-to-end testing, the fix often touches multiple parts of the system across different layers. Each test level provides different type of confidence. If you have a very high unit test coverage, it doesn't guarantee that all components together will work correctly. On the other hand, you can have a single end-to-end test that might cover a whole workflow, but it won't validate all possible data variations and edge cases. And finally, the cost. The more complex is the logic your test exercise, the more complex the setup becomes. Inputs and outputs grow, surrounding systems needs to be prepared or mocked, and the number of potential failure points increases, including flakiness. Each level of testing pyramid protects different kind of risk. Unit tests protect internal logic, things like calculations, transformations, and decision logic. This is the level where it makes the most sense to try different input and output combinations because the feedback is fast and the setup is simple. Integration tests protect boundaries and contracts. This includes APIs, database interactions, and communication between larger components and services. The purpose of them is to verify that parts of the system work together correctly, not just in isolation. End-to-end tests protect critical business workflows. They verify that key system functionality can be executed end-to-end and that high-level requirements are met. Because they cover a lot of moving parts, they are usually fewer and more expensive to maintain. To make this more concrete, let's look at the simple real system. Imagine an e-commerce order backend service. The order service exposes API to the client, stores data in database, and communicate with external payment system. At the unit test level, we focus on internal logic inside the order service. For example, the state transitions rules, such as if an order can go from open to cancelled or open to paid state. This is also where it makes sense to test mapping logic, such as transforming a payment event into internal order representation. These tests are fast, isolated, and provide quick feedback on logic errors. At the integration level, we verify how order service can interact with its direct dependencies. This includes persisting and retrieving orders from real database and handling responses from the payment system. For example, we test that a valid payment move order from open to paid state, or that the payment from cancelled order is rejected. Here we test boundaries and contracts, but not full workflow. And finally, at the end-to-end level, we validate complete business workflows. For instance, a client creates an order, the order is stored as open, the payment arrives, and the order becomes paid. The client cancels an open order and sees it move to cancelled. These tests verify that systems works correctly as a whole, but because they are slower and more expensive, we usually keep only a few critical ones. This is how testing pyramid translates into real system, each level protecting different kind of risk. Now you know that the testing pyramid isn't about test counts. It's about content, intent, and risk. If you want to keep learning how software quality works in real-world systems, feel free to subscribe. Thanks for watching. Bye.